So now that we have this idea of vector valued functions, we can now talk about limits and continuity. So back in Calculus 1, that's one of the first things you do when talking about functions is you talk about limits of functions and whether or not a function is continuous or not. So before we do that, let's talk about how to add these vector functions together. So let's say R1 is going to be the vectored function. We're just going to work in 2 dimensions, but you'll have something similar in 3 dimensions. So in space, G1Tj, and R2 will be the function F2Ti plus G2Tj. And then how do I add and subtract these functions together? So what would R1 plus or minus R2 look like? Well, do you remember how you added vectors together? You add in the ith in your x component and you add in your y component. So it would be F1 plus or minus F2 I plus, and then you add or subtract in your j component, G1T plus or minus G2T, and then this will have a j on it. Running out of room here, sorry about that. And then what if I want to take a scalar multiple of a vector functions, t times r1, what would that look like? Or c times r1? Well, how do I do a scalar multiple of a vector? You essentially just distribute it out into each one. So this would be c times the function f1 plus c times the function g1j. All right, so now that we know how to add and subtract these vector functions together and how to do scalar multiplication, we can talk about limits. So the limit of a vector valued function So I'm just going to state it in the 2-dimensional case, but you have something similar in 3 dimensions. So if r of t is f of ti plus g of tj, then when I take a limit as t goes to a of r of t, you're just going to take the limit of each of the component functions. So f of t plus the limit of g of t j, provided f and g have limits. And again, you would have something similar if you had a k component. The limit would just be, you would have 3 limits instead of 2. Okay, so that's how we're going to talk about limits. The next thing is how to talk about continuity. So continuity of a vector function. So we're going to say that r, our vector function r, is continuous at the point given by t equals a, when 2 things have to happen. So when the limit as t goes to a exists, And this limit has to be the same thing as evaluating my function at a. So again, this is just like how it worked for functions. In order to be continuous, the limit had to exist and it had to be equal to evaluating your function.